In today's video, we're going to go ahead and practice permutations and combinations number 1. So before we start, let's review real quick the difference between each of them. So a permutation, order matters. So when you're working with a permutation, the order in which you pick things matters. For a combination, order doesn't matter. So that is the main difference between these two types of problems. So whenever you're working with permutation, the order in which I type these in, like a code or office, the way that I work with these, the order makes a difference. If it's a combination, the order doesn't matter. So it doesn't matter how I organize these things. It doesn't make a difference. The order does not matter. So on 1 through 4, we're just stating if these are permutations and combinations. So number 1, it says a team of 8 basketball players needs to choose a captain and a co-captain. Well, captain and co-captain are two different things. Like you're the captain and then you're the assistant captain. So when you're working through these problems, captain and co-captain, that is a position. So this is going to be a permutation because I am dealing with positions like offices. Captain and co-captain, those are two different things. And if I'm the captain, I don't want to be called the co-captain. Like I want to be the captain. Number 2, Rob and Mary are planning trips to 9 countries this year. There are 13 countries they want to visit and are deciding which countries to skip. Here's the thing about this problem. Rob and Mary, they don't have any feelings about the countries. They're not like, oh, we have to go to Rome. Like that. We got to go to Italy to go to Rome. Like we have to do that. They don't care. Like they have no emotions. So it doesn't matter if they go to Italy first and then Ireland or vice versa. They don't mind which ones they're skipping. So this is a combination because it doesn't matter if they go to Italy first or Ireland first. What matters is that they go. So the order in which they attend these, since it doesn't say, that they're going for different time measurements, they just want to know which ones they're going to skip. So this is a combination. Number 3, a batting order for 7 players on a 12-person team. I am putting these people in a specific order. Anytime that happens, it's a permutation. So the order in which I put people in a batting order matters, okay? If I put the pitcher first and then I change it to last, I've rearranged the order. Number 4, if there are 45 applicants for 3 computer programming positions, it doesn't matter if I hire you first or second or third, you're still a computer programmer. So this is a combination. The jobs aren't different. They're all the same. So it doesn't matter if I pick you first or last. Okay. Number 5, state if each scenario involves permutation or combination, then find the number of possibilities. We will show that it's a permutation or combination based on the work and whether or not we use P or C. So it says Castile and Joe are planning trips to 3 countries this year. There are 7 countries they would like to visit, but one trip is going to be a week long. Another is going to be 2 days, and another is 2 weeks. Notice how these trips, these are different lengths of time. It's a totally different trip if I spend 2 days in Italy versus 2 weeks in Italy. So the order in which I select the countries changes the outcome of my trip. So this is a permutation. So I'm going to put a capital P. And then remember, the N value is the value of numbers that you are picking from. So we are choosing 7 countries. So our N value is 7 because we are going to we have 7 countries to pick. However, we can only go to 3 of them. Bummer, we can only go to 3 different countries this year. These people must not work. So this is a permutation. So I'm going to do this 2 ways. The first method is with the TI-84 plus color edition. If you have this calculator, you're going to go to math, over to probability, and you're going to select option 2 for permutation, and boxes are going to pop up, and you're going to put 7 and 3 and press enter. This only works if you have an 84 plus color edition. So now I'm going to go to the older models, which are the ones we have in class. So if you have an Inspire with an 83 plus or just a plain 84 plus silver edition, things like that, this is how you'll type them in. So you'll type in your 7 first, the end value is first. Then you go to math, over to probability, select option 2, and then you type the R value. And the calculator is going to keep N and R in the actual calculator, but it knows that the first number you put is N and the second number you put is R. So it's going to also give you the same answer. So just be mindful, the calculators are different. They both give you the exact same answer. It's just one is typed in differently than the other. So if you have the color edition 84 plus, yours is going to look nice and neat, whereas the older interface on the 83 plus and the 84 plus, as well as an Inspire, if you're using the faceplate for an 83, they're going to look a little different, but it's the same thing. Okay, so if you're unsure about your calculator, just go to probability and select P and C and see which one is, how it looks, and that will tell you how to type it in. So I'm going to be continuing the remainder of the problems using the plus color, just because I think it shows up a little bit nicer on the screen when I'm filming. So that it's purely for vanity reasons. So I'm going to put this answer as 210. There are 210 different combinations. Number 7, we skipped number 6 because honestly, I'm not going to even lie. I have asked so many people about number 6. It was about holding hands or like shaking hands. And all the different people I talked to, some thought it was permutation, some thought it was combination. I have yet to find the correct answer. So I just flat out whited it out. So we're just going to pretend like number 6 didn't exist. So number 7, you're setting a combination on a 3-digit lock and you want to use numbers 1, 2, 3. So like these are individual numbers, number 1, number 2, number 3, but you don't care what order they're in. So here's the thing, like just because you don't care what order they're in doesn't mean the combination lock, like the lock that you're setting the code for, doesn't matter. Like you need to know that. So any type of digital lock or any type of combination that I am putting a PIN number, a code to my phone, anything with numbers and the number order matters. It doesn't matter if you don't care, but if the number order matters, then it is a permutation always. Well, in the permutation, you are using numbers 1, 2, and 3. So there are 3 numbers and you have to use all 3 of those numbers in your code in any order. So it's 3P3. So I'm going to go into my calculator. Again, I'm going to go over to probability, select this, 3, 3, and there are 6 different ways I could write the code. Number 8, a group of 25 people run in a race. The top 8 finishers advance to the finals. Well, I'm taking the top 8, so it does not matter if I come in first place or 8th place. I'm going to the finals. So this is a combination because the order in which I finish, as long as I'm in the top 8, I'm going. So there are a total of 25 people competing, but they're only going to take the top 8 competitors. So only 8 people get to go. So this is a combination. So let's switch interfaces. All right, let me adjust it so you can see it. There we go. So I'm going to put 25, math, probability. I'm going to choose option 3 this time for combination. And then I'm going to put 8. And there are a lot of combinations. So 1, 0, 8, 1, 7, 5. I'll go back and put my commas. There are 1,081,575 different ways you could go to the finals. Number 9. A team of 17 softball players needs to choose 3 people to fill the water cooler. So in this problem, we are just selecting at random 3 people. It doesn't matter if I, 3 players to refill water. It doesn't matter if I'm picked first. Like I don't win like a lucky prize that I am the first person to get picked to fill water. It doesn't matter. We're all the same type of people. We're all going to fill water. So this is just a combination because the order in which I was picked does not make a difference. However, there's 17 total softball players on the field, but I am one of the lucky 3. So I'm only picking 3 people here. So switch interfaces. We're going to go to math, probability, 17, 3. There are 680 different ways I could be selected to fill water. Remember, it doesn't matter. These people in these problems don't have emotions. They don't care if they're picked first or last, as long as they're picked. Number 10, 5 out of 13 students will ride in a car instead of a van. Well, it doesn't matter if I'm called first to sit in the car or if I'm called fifth to sit in the car. So these people are just riding in a car instead of a van. Like, that is not a specific order. I'm just putting these people in cars. Well, there is a total of 13 kids. And then out of those 13 kids, only 5 are chosen. So this is a combination. Switch interfaces again, just to, go back and forth between the two. I'm hoping that if you have a newer calculator, you obviously know how to do it by now. But these are the calculators I have in our class. So I want to make sure that I am covering how to do these because I don't expect you to buy like a color calculator. So there are 1,287 different ways you could put these 5 kids in a car instead of a van. Next, number 11, the student body of 10 students wants to elect a president, vice president, secretary, and treasurer. Okay, here's the thing. We are electing people to be different roles. So this is a permutation. It matters if I win the presidency for my student council and I am now a treasurer. Like, I don't want that. I want to be president. I won presidency. So in this problem, there are a total of 10 kids that want to be in these positions. And in this case, there are 4 offices that they can choose from: president, vice president, secretary, and treasurer. So instead of them just flat out saying, hey, there's 4 offices, they're telling you the 4 offices. So this is a permutation. Oh, that is not the clear button. So math, probability, 10 and 4. So there are 5,040 different ways these kids can be elected into the offices. Number 12, selecting which 7 players will be in a batting order on an 11-person team. Now, this problem, we talked about batting order and how batting order is permutation. However, we are not putting them in the batting order. We are selecting the kids who we will eventually put into the batting order. So we are just selecting which kids will be in the order. This is a combination. We haven't put them in order yet. We're just saying, okay, these 7 kids, you're our players. We will eventually put you in order. So in this problem, I have a total of 11 kids on the team. However, only 7 of those players I'm going to put in an order. I'm not putting them in an order right now, but I will. So this is a combination. So option 3, 11, 7. So I can arrange these kids in 330 different ways. Number 13, there are 15 applicants for 4 jobs: computer programmer, software tester, manager, and systems engineer. Well, in this problem, I am hiring people. But these are all different jobs. It's not like, oh, we're all computer programmers. No, one of you is a manager. So that means that it's a permutation because it matters that if I was hired as a manager, you don't put me as a system engineer. So in this problem, it's a permutation. We have a total of 15 people applying for this job. However, we are only going to pick a lucky 4. So it's a permutation. So I'm going to go over here. I'm going to put 15 first since I'm using the older interface. Go over to probability, option 2, 4. And there are 32,760 ways we could be hired for these jobs. So remember, when you're using different interfaces on your calculator, it's okay. Usually if you have an app, you probably are picking the newer calculator, so you'll be using it like this. But when you take your test, if you don't own one, you have to use the one in my classroom. You can't use your phone calculator on the test. So you do want to be comfortable with both. That's kind of why I'm switching back and forth between the brands, just so you can kind of see and get revisited on how to use what. All right, the very last one, a group of 45 people are going to run a race. The top 3 runners earn gold, silver, and bronze medals. Here's the thing. They are earning gold, silver, bronze. If I come in first place, I want gold. Don't give me the bronze medal. So this is a permutation because it matters who wins first, second, third. There are 45 people running this race. And out of those 45 people, there are only 3 runners that get to win prizes first, second, and third. So this is a permutation. Going into my calculator, math, probability, option 2. Oh, don't press enter. It's going to give you an error. Go back over. So 45, arrow over to 3. There are 85,140 different ways we could place. So remember, when you're working with permutations and combinations, personal feelings should be out of the problem, meaning it doesn't matter who I pick to ride in the car first. We're all going to the car. However, if we're running an election, if you win the presidency, you want to keep the presidency position. So just remember, combination is when the order that I pick doesn't make a difference. Permutation is when the order in which I select people matters.